properties of rhombuses, rectangles, and squares. 6.4, you have those, if you'll get those little note sheets out that we started, they had a bunch of rectangles all over them. Okay. Look like this, actually. Just a little review of what we did so far, and then we're going to add to it so you can get your pencil out. We already talked about parallelograms. Parallelograms have opposite sides congruent, opposite angles congruent, consecutive angles are complementary. Did I say complementary? I meant supplementary. Diagonals bisect each other, and then we can use all of those, the converses of those, to prove a parallelogram. And then we can use one more, that one pair of opposite sides are congruent and parallel. We're going to add to these quadrilaterals today. We're going to add something down here. Two more, so you can put some arrows there for you. We're going to add two, actually three. We're going to do those all those down at the bottom down there. We're going to add that down there. And those two are a rhombus and a rectangle. So a rhombus is just a quadrilateral parallelogram. That's what, so that when we draw this line down here, we're including, it's coming from the parallelograms. So it is a special parallelogram that has all its sides congruent. And I drew it down here. We can actually label it because I don't have any markings on it. So that would mean that all four of those would be congruent to each other. A rectangle has all angles congruent. All right? I would suggest that you write that in there as small as you can, because we're going to have, even next week, we're going to add formulas on how to find areas of these things, and so you'll have formulas in there too. So, and I've drawn a picture of a quadrilateral here, a parallelogram, but the angles are all equal. So what do they all add up to be in a quadrilateral?
180.
360. And so if I took that 360 and I divided it by 4, because all of them are equal, what would I get?
80.
You'd
No,
get
90.
Would I get 90?
Mm-hmm.
Yes, we would. So they're all 90 degrees. I'm going to draw them 90. We talked about a little while ago that we don't really have to draw all of them. If we just drew one of them, it would imply the rest, because these two are consecutive, so they're supplementary. These two are opposite. So we really only have to draw one, but just for the sake of saying, since they're all congruent, I'm going to put them all there. Okay. Questions so far? All right, now we're going to draw, the next thing we're going to do is put 2 there. We're going to combine both rhombuses and rectangles together for one shape. A shape that has all sides congruent and all angles congruent. Can anybody tell me what they think that might be?
Square.
It's a square. That is exactly right. A square is going to combine both the fact of, as a rhombus, both with a rhombus and a rectangle. It'll be a square, so it'll have all sides and angles congruent. So I'm going to just put 190 degrees, just for the sake, to make it easier down there. You're going to have at least a formula and in there next for the square, so make sure that you keep room for it. Now, if something is a square, is it a rhombus? Is this shape I drew down here, is that shape a rhombus? Is all its sides congruent?
Yes.
Yes, okay. Is that shape down there a parallelogram?
Yes.
Yes. Is it a quadrilateral?
Yes.
Yes. The square, in a sense, is all of them working its way up with the arrows. We will have 2 more on the next lesson that it will not apply to, but since the arrows come clear down, starting up here with a quadrilateral, then to the rhombus and the square, so anything above it is true. Okay. So is a square a rectangle?
Yes.
Yes. A square has all angles congruent, so a square is a rectangle. Is a rectangle a square?
Not necessarily. No.
All rectangles are not necessarily squares, but all squares are rectangles. Are all squares rhombuses?
Yes.
Every single square you could draw would it be a rhombus? I have yeses and nos. It is? Why, Brett?
Because a rhombus has all sides congruent and a square has all sides congruent.
Yes. Are all rhombuses squares.
No.
And I have an example of one right there. That one is not a square because its angles are not all equal, or all 90 degrees. Okay? So, depending on the question, be real careful on how you get stumped. You could get stumped on that. All right? Let's do some properties. You have a theorem already in your postulate book, possibly, and this is the one you needed to draw a picture for that we were going to compare. So if you want to look at that now, it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So I right here have a rhombus. I have drawn the parallel sides.
Yeah, we got it right, Amy.
I did not draw the congruent lines though. What congruent lines do I need to write for a rhombus again?
Which one is this one? Is this?
All what?
The sides.
All sides. So I need to make lines on all those. They are all parallel. The opposite ones are parallel, by the way. And all of them are congruent. But the cool thing is the diagonals are perpendicular. What else do we know about its diagonals based on it being a parallelogram? They bisect each other, okay? Just because it's a parallelogram. So rhombuses are parallelograms, so they have all of the properties of a parallelogram, plus extra, their diagonals are perpendicular. Another one you have in your book, and you needed to draw a picture. Hopefully you, if you didn't, it's okay, you can draw it now. A parallelogram is a rhombus if and only if its diagonals bisect the pair of opposite angles. So, I have right here. Now, they drew, or I drew, these have singles, but these one has doubles. Are the angles congruent? Shouldn't we just all do?
No, because that'd be a rectangle.
Ah, so, okay. All right, that makes sense.
But the thing is so angle B when it's bisected is the same as angle D when it's bisected?
Yes, why?
I'm not sure, because I did not draw that on mine.
Okay, so a parallelogram,
Up to 4, which
I'm going to draw just a parallelogram that's not a rhombus, okay?
Okay.
What do we know about opposite angles?
Oh, they're congruent.
So, is this a parallelogram?
Yes.
Yes. Okay, so it's a parallelogram. So all of the properties of a parallelogram apply to rhombuses plus these extra. The question is, do these apply to also squares? Is a square a rhombus?
Yes.
Yes. So these apply to squares also. This is about rectangles. A parallelogram is a rectangle if and only if its diagonals are congruent. So here's our rectangle. Did we talk about this one already? We talked about this one. So we have here, and they drew single lines. Why did they only draw singles? Shouldn't they have done doubles on at least one?
Not necessarily. They can, because since they bisect each other. We drew doubles, but it could be.
Will they always be this way? What if I drew a rectangle really, really long? Would this diagonal equal that diagonal?
Yeah.
Yes. If I cut it in half, would that half equal that half?
Yes.
Why can I cut it in half?
They bisect each other.
Why couldn't I cut him in? Why am I cutting him in half? What property says anything about cutting him in half? Yes. And what does it say, Brett? Go ahead. That's perfect.
Diagonals of a parallelogram bisect each
That's
other.
correct. Okay, so a rectangle is a parallelogram, so its diagonals bisect each other, correct? So if we knew that the whole diagonal was congruent, should the halves be congruent? If this was 10 in length, and the other one was 10 in length, then half of it, both of the halves are going to be how much? 5. So the halves will be equal, won't they? All right, so we only need single lines because the diagonals bisect each other. Will this apply to rhombuses? Are rectangles and rhombuses the same?
No.
Will this apply to squares?
Yes.
Yes, because squares are rectangles. All right. All right. We're going to do some examples now. So you're going to open up your assignment sheet. It looks like this. I've highlighted the ones we're going to do, 1, 4, 6, 9, and 13, and 14, so you can get an idea how this little thing works. You will be bringing out that note sheet again, so just so you know, we'll be using it again when we talk about squares. Actually, no, not when we talk about squares. On our next
Are we
lesson.
just doing it, or are we doing it together?
One more time.
Are we doing it by ourselves?
No, we'll do this together. I just want to make sure everyone has it out. All right. So the top up there, the instructions tell us to place an X in the box if the shape always, and the key word is always has the given property. Not sometimes, but always. So the pair of opposite sides are parallel. Which of those did you learn last week have opposite sides parallel? Where did we learn about that?
Parallelogram.
Parallelograms, okay. So what else will opposite sides be parallel? Will it be for any of the others?
Yeah, the rest down the line.
Which direction?
Everything else after the parallelogram.
So rhombus
going towards
will,
the right, yes, because they're all parallel.
rectangles and squares, not quadrilaterals?
No.
Can I draw a quadrilateral that does not have opposite sides parallel? If I go like this one's not going to be, let's see. I have to draw that, something like that, right? And then I could draw, doesn't have opposite sides. Almost does, though, if I would have just made this one a little longer. That way I have it. Those are definitely don't have opposite sides parallel. All right, number 4. The diagonals are perpendicular. Which ones did you learn anything about diagonals being perpendicular? Just now. We just wrote we just had it in your Pashto book.
Wait.
You're welcome to look it up. Actually, you know what? We might pause this for a quick minute, not do this part, just a second. And put in the facts we just learned about rhombuses and rectangles on your note sheet.
Huh?
Let's do that real quick before we go on.
Is that-
All right, so number 4, diagonals are perpendicular. So now that we've written it on your review sheet, or your sheets there, your notes, which one did we write that diagonals are perpendicular?
Rhombus
On the rhombus, okay.
and square.
So, and if it's a rhombus, does it apply to anything else? Square, yes. I'm hoping that us getting it on those note sheets is going to be much more helpful than going through your Pashto books. Number 6, the diagonals bisect each other. Where do the diagonals bisect each other? Which one did we write that on? We might have written that even last week.
Parallelograms on.
So we wrote it on parallelograms right there. All right, so we wrote it on parallelograms. So everything that is a parallelogram, it applies to that. So is a rhombus a parallelogram?
Yeah.
Yes. Is a rectangle a parallelogram?
Yeah.
Is a square a parallelogram?
Yeah.
All right. Number 9. The figure has 4 right angles. Which of the figures have 4 right angles? Squares do, I agree.
Rectangles?
Rectangles do. Very good. Anything else? No. Let's move down here. Down to the bottom. Place an X in the box for all the possible names of the given shape. All the possible names of the given shape. Obviously, if the figure is a rectangle, it will be called a rectangle. So let's put a rectangle in there.
Could also be called square.
Is a square a rectangle?
A square is,
Yeah.
but
So-
a rectangle isn't always a square.
That's correct. So I want to know, if you have a rectangle, can you call it a square?
Not always.
Okay,
always.
can you call it a rhombus?
No.
No.
Can you call it a parallelogram?
Yes.
Yes.
Okay, so it can be called a parallelogram. What else can it be called? A
Quadrilateral.
quadrilateral. Okay. This time we're not going down the chart, your note sheet, we're coming up. So if it was a rectangle, we follow the arrows back up. All right, so now we're going to do a rhombus. If it's a rhombus, it can be obviously called a rhombus. But what can it be called a rectangle if it's a rhombus? No. Can it be called a square?
Not always.
Not always, sometimes, but not always. And
So we wouldn't.
so we wouldn't put it on.
Oh.
So can a rhombus be called a parallelogram? Yes. Can it be called a quadrilateral?
Yes.
Yes. All right. I'll let you finish those down there. Not for your homework. All right. We're going to move to the next page. Turn it over. We're now going to do some math. We're going to do some, and I guess we've been doing math all along. I meant numbers. We've been doing math all along. This has got a lot to do with reasoning, so you're going to do a lot of reasoning on that first page. Number 18, it's telling you that A, B, C, D,
It's a square.
it's a square. Okay, what do you know about squares? Has 90-degree angles. They're asking us to find X. So how are we going to make an equation out of that? Yes. Why do we need that 18?
We don't.
We don't. We don't. All right. So we're going to divide by 5. X equals
18.
18, I heard. Somebody confirm that.
18.
All right. This one says, number 20, says that KLMN is a rectangle. What do we know about rectangles? Their angles are 90. And they also do what?
They're congruent.
They're congruent. We have two things we could do here. We could set these equal to each other. What else could we do? Set them equal to 90. Which one would you prefer? Either one of them would get the right answer.
I set them equal to each other.
Okay, she set them equal to each other. You do that way, and we'll see if we get the same answer as if we set this equal to 90. Which one would you like to set to 90? The x plus 40 or the 2x minus 10? I like that one too. So we're going to x plus 40 equals 90. All right, so I'm going to move the 40 over by subtracting it. So x will be how much?
50.
Now, is that what you got? I'm going to check it just to make sure. If I plug the 50 back in there, would I get 90 again? I want to just check to make sure I did it right.
I was just behind.
2 times 50 minus 10. What does that equal? Does it equal the 90 I'm looking for? This is 100. And 100 minus 10 is how much? What's 100 minus 10? Anybody?
90.
I got one person saying 90. Do you agree? It's 90. Yes. This says that TUWY is a rhombus. What do we know about rhombuses?
All sides are congruent.
All sides are congruent. So what equation can I write with this?
X plus 2 equals 3x.
That's what I did.
Okay, I'm going to move that x over there by subtracting. So we'll have 3x minus x is just going to be 2x. Divide by 2 on both sides, and x will equal
1.
1.
You got. What did you get for your top answer? You got 50.
50, yeah, I should have circled this.
And 18.
I should have circled
Okay,
this
yeah,
one.
I got the same thing as you guys.
There we go. Now we're going to do some more. Turn the page. I think it's the next page over. 24, 26, and 28. It now wants us to list all the possible names for this figure. All possible. What kind of shape is that? Is it a...
Quadrilateral.
It's a quadrilateral. I agree with that. What else? Is it a parallelogram?
No.
No.
So if it's not a parallelogram, can we even go down your page? Can we call it a rhombus or a rectangle or a square? No. So if it's not a parallelogram, we can stop. Number 26. Do you guys want to start at the top of your chart and work down? Or do you want to start
I've done it both ways.
It doesn't matter because I don't care what order you write the words in.
I probably should stick with the same. Let me start at the
Top. So is it a quadrilateral? Yes.
Is there an abbreviation for that?
You could just do quad.
Please.
So coming down from there, we haven't branched off on the other two sides anyway. So is it a is that a parallelogram? Yes. So we know that opposite sides are congruent, so we know it's a parallelogram.
Oh, that one.
I love the word parallelogram. It kind of rolls off your tongue. Okay, so can we even go further? Is it one of the special kinds?
It's a rectangle.
It isn't a rectangle,
Oh, I know, I'm sorry,
but
I
it
mean
is
rhombus.
it's a rhombus.
Rhombus.
Yes. So since it's not a, since Brett, you said we said it's not a rectangle, does that make it a square?
No.
No, so we're done. Okay. All right. Number 8. Start at the top, because that's what you guys said you wanted to do. Is it a quadrilateral? Yes. Is it a parallelogram?
Yes.
Yes.
What is it after that?
Square.
Square.
Square. Okay.
And rectangle.
And rectangle and
Rhombus.
rhombus. It's everything.
I'm gonna redo that one because I started. That's the only one that I started backwards.
Okay. Guess I spelled out the rhombus, but not the rest. It's a quadrilateral, rectangle, parallelogram, square, and rhombus. Basically, if it's a square, what do you know about it?
It's everything.
It's everything else.
Yeah.
And if it's not a parallelogram, then it's only a quadrilateral, right? Okay. These ones are intended for you to see connections between all of the shapes so that you can make sure you know that the properties that are associated with parallelograms flow down to the rest of them. The properties that are with quadrilaterals flow down to the rest of them. All right, so I want you to remember that a rhombus is a parallelogram with 4 congruent sides. And since it says the word parallelogram in there, that it is a parallelogram, its properties, parallelogram properties, apply to rhombuses. Is that rhombi, if it's rhombuses, rhombi? I have no idea, I'm teasing. A rectangle is a parallelogram with 4 right angles, or 4 congruent angles. Since it's a parallelogram, all the properties of parallelogram flow down to the rectangles. And a square is a combination of a rhombus and a rectangle. So all properties of rectangles and rhombuses apply to squares. Are there any questions about this? All right, we're done with this.